Welcome to my channel Dr. Munshi Nasser Skeleton. How are you my dear learners? In this video we are continuing the econometrics using R programming language, and we are following the Florian Heiess book, and this book and all other materials I am going to share in my video description box so you can get all those things very easily. So today we are going to cover the rest of the chapter 2, and then hopefully you can understand some of the basic assumptions of OLS, and then gradually when we move forward we will discuss about new topics, new chapters, and we will complete this econometrics journey using R programming in my channel. So hope if you are interested this kind of content, please do subscribe and share your content with other peers so that everybody can learn and we can increase this community. Okay, so let's get started. Today we are going to talk about the non-linearities. In the last video we have discussed the goodness of fit, as well as how to find correlation, coefficients, residuals, and all those information using our programming language. And we understood that what is the meaning of goodness of fit, how good is the model is, and all that. So now in this particular section, 2.4 section of this book, we are taking the example called the wage and education. So often in economics we usually find some of the models are not linear. Sometimes, for instance, elasticity in this case, it's a ratio, so it's a percentage change of a quantity demand divided by the percentage change of a price. So it's not a directly linear model, right? So in order to convert your any non-linear model to linear model, we use the log term, and this log term we can use to make it a linear function of the model. So it says for the estimation of logarithmic or semi-logarithmic models, the respective formula can be directly entered in the specification using the LM command or linear model command or function of the R programming. We are taking the same example, wage and education, and here you can see that the script are very clear. This book has a very nice script, so you can just have follow and type in the in R Studio, so you can practice by your own time and you know how I already demonstrated how to do those things in my previous two videos, so of course you know how to do those things. Okay, so what we have done, we use the data wage one, which is a Aldrich book data, so we need to upload the package Aldrich and then estimate the log level model simply using the LM command, which means the linear model function, and then use log wage. Log, when you take the log, it will be the variable should convert it into the log model, and then you regress the education. There are two variables, wage and education. Wage is a dependent variable, education is independent variable, and we are using data wage, and that's what it gives. The intercept is 0.58 and the education variable it gives 0.08, which means 8% of the education is explained by the model, and of course it says that 1% change in the education, it will increase that 8% rise in the wage level. So basically 1% change in the education status of any worker, it will enhance the wage rate 8%. So that's what it says, the relationship wage and education. And then we also use the log model. So in here we use a semi log model where we use only log before the dependent variable. However, in here we are using both the models, both the variables using log. So this is a log model, and since we are expecting that this is a completely a non-linear model, so in order to complete and in order to use a full log model, so that you can convert your non-linear function to a linear function. And remember my dear learners, in OLS assumption, one of the most important assumption, and in fact the first assumption, is the linearity. So you see the ordinary least square model, and that's what the first assumption, meaning that it's supposed to be a linear model. So linearity is a very important assumption for OLS regression. That's what how we can convert a non-linear function to a linear function. We are using log as a means or methods of doing that. Okay, now going regression through the origin and regression on a constant. In order to think that the value of the regression, for instance, if we can use a small diagram, let's assume that if our model is going to the origin and there is another model which is using intercept. Okay, so there is a constant and there is no constant. If that is the case, okay, in that case what would be our regression looks like? And that's what it says in here, that if there is no intercept, that's why it says y dependent variable regressing no intercept plus x. And instead of writing this, you can write like this. The result of this will be slope parameter will come like this, and this is one that is going through the intercept. Okay, very simple, and there is an example given here as well. So moving on, we are now discussing about the assumptions: expected value, variance, and standard errors. This is a very important 5 assumptions that we are going to talk about in this video, and the next video we will gradually see how the heteroscedasticity, multicollinearity, how we can check and how to interpret those things easily using this book information, and of course the R programming. Okay, so already discussed the role of 5 assumptions under with the OLS parameter estimators and describe and their desirable properties. I mean, in order to fulfill an OLS regression, you need to fulfill these 5 assumptions. And in my opinion, in my research experience, it says that whenever you run a OLS regression for a cross-sectional data, you need to test these 5 assumptions in order to say that your model is a good fit or your model is a good model. Without testing these 5 assumptions, in my opinion, your work will be, I should say, half done, and therefore it will not be accepted by a good publication in future. So therefore what you have to do, you need to check those assumptions one by one. And the first assumption, as I said, it's a linear population regression function. So linearity is very important, and we need to check the linearity. There are many ways we can check the linearity, and that we will do in the next video, of course. And next couple of videos and the whole video series we will discuss about this econometrics using R programming and following this book. So don't worry, please be with me and we will go slowly in each classes. Okay, now the second assumption is a random sampling of x and y from the population. So the random sampling meaning that it should not be biased. It should not be biased when you draw any sample information from the population. You need to be very careful that this is not a biased sampling. It's supposed to be a very random sampling, and therefore you can have a very accurate results. So that's why it says random sampling. And then the third assumption says variation in the sample values. Okay, so if there is no variation in the sample values from x1 to xn, then there is no point of running a regression, right? Like for example, if you are running something dummy variable like 0 0 0 0 or 1 1 1 1, so what is the point of running a regression using these dummy variables or dummy values? So that's what it says, that variation in the sample values that can only show you whether your observations are good fit for the linear model. And one of the important and in my opinion most important 2 points are the assumption 4 and assumption 5. And assumption 4 says 0 conditional mean. And what does it mean, 0 conditional mean? It's very important to understand what is 0 conditional mean. If we look at the value here, that the 0 conditional mean, the equation gives like this. Okay, so it means that the expected value, or you can say mean, this expected value, in other words we also call the mean, it's supposed to be, these two mean will be 0. So which means that they are not correlated, their mean not dependent, their mean should be independent. What if this assumption is violated? And if this assumption violated, what will happen, my dear learners? There will be a problem called the endogeneity problem. Okay, there will be a problem of endogeneity problem, because then the regressor and the error term are correlated. And in many cases we use instrumental variables and we find causality and all those issues come up, and we need to rectify the problem when we have this kind of relationship. So the regressor or the independent variable should be mean independent, not mean dependent, and especially not dependent on the error term. So it says 0 conditional mean, meaning that it will not conditioned or depending on the mean value of error term. And in other words, we should say the regressor should be mean independent, and that's what it says. Otherwise we might face the problem of this endogeneity, and the endogeneity problem will lead you to biasness problem, and therefore your model will not be accurate. The next one is called the homostochasticity. It's a something called the opposite of heterostochasticity, and heterostochasticity meaning that the conditional mean here, instead of saying conditional mean, we are using the variance. Okay, variance, this is the variance, and this variance will be constant. Okay, so this variance will be constant. Okay, so there will be no such thing, for example a variance should be correlated or something like that. It should be constant. Okay, and that is what it says, the homoscedasticity, or the variance will be there, the mean error term and the regression variance should be constant. If this is not constant, then we find the heteroscedasticity problem, and when we find this heteroscedasticity problem, we need to test that issue, and we need to find how to solve those issues. One of the way you can solve is taking the log, or you can say the linear ln of the regressor, or sometimes you can take the difference of the regressor, first difference or second difference. So all those things we will discuss in the next chapter, because next chapter is all about the multicollinearity and heteroscedasticity, so we will discuss those things gradually. Now the theorem 2.1, it says that the 1 to 4, these assumptions, OLS parameter estimators, are unbiased. So these 4 assumptions, okay, you see, remember the ordinary least square is called the best linear unbiased estimation, right? Blue results, best linear unbiased estimation. So best linear, so linear is the, of course, linearity, unbiased estimation. So first 4 assumptions we'll discuss about this unbiased properties. And 1 to 5 OLS parameters estimators have a specific sampling variance, which means, as I said, constant variance. Because the formulas for sampling variance involve the variance of the error term, we also have to estimating it using the unbiased estimator. So therefore this value should be estimated. Now talking about these issues, if we go move on, and there is another called the standard error of regression. Now what is the standard error? Now my dear learners, there is another video in my channel from Discovering Statistics with Dr. Munshi. I request you to look that playlist, so you will have a basic statistical knowledge. But for this video's sake, standard error meaning that a distribution, the population sampling distribution, the probability of the population sampling distribution is called the standard error of the estimates. Like for example, standard deviation, the distance between mean and the observation, right? Now here it says that the probability of distribution of the sampling distributions, like for example there are 4 sampling, you 4 samples, and you take their distributions and you represents using the checking the distributions variance. I mean, what is the difference between first sample and second sample's distance, or the probability of the values. So that is called the standard error of the estimators. So you need to check those things in order to find out your sampling distribution and the residual standard error. So basically the 4-5 assumptions, these are the very important, and then we will discuss more in detail about what is heteroscedasticity, how can we find that, what is the what will happen if it will violated, then multicollinearity, what do you mean by multicollinearity, like these things we will need to discuss later on. So if we move on, there are some example here given. Okay, now there is another one called Monte Carlo simulations. Monte Carlo simulation is like, for instance, if you don't have a sample to work with, and for example, in other words, we say that if you have a limited sample size and you need to increase your sample size so that you can find a more robust result, in that case the automated simulation technique is called the Monte Carlo simulations, because using this simulation technique you can enhance the sampling observations on numbers, and you can take those numbers as a part of your estimation so that you can have a robust results. In other words, we can say in machine learning we call the k-means neighbor, or we can say that bootstrap sampling. It's very close to that type of sampling method. This is just to for simple manner, it is a iteration process of sampling. For example, if you have a small sample, then you take an iteration and like a permutation or combination way, and there will be many sample size you will find from that bunch of small sample, and there you can enhance the number of samples, and then you run a regression on each samples that you iterate from each time. That is called the Monte Carlo simulation. So this is not the usually or conventional econometrics issue, but just to remind you or just to clarify what does it mean actually. And there is a nice example given here, and I would recommend you to like how to create this many samples. Like for example, it says 10,000 samples, how we can do that using loop, and those things we will do it. Like for example, set the seed like 1 2 3 4 5 6 7, this is the seed, and then we need to create a artificial sampling or observations of 10,000 samples, and this is how we can do it by R programming. But I recommend you not to be panicked using this Monte Carlo simulation at this moment. You just need to know what does it mean actually. Okay, now with that note, this is the last topic of our what do you call it, the regression chapter 2, OLS regression and its assumptions, and we will discuss more about this violation of the assumption 4 and assumption 5 in more detail in the next video, in the next chapter as well, because in the next chapter I believe the section called the multiple regression analysis, and that's what we will do in the next tutorial. So I will hope and see you in the next tutorial. Until then, bye bye.